Find the points of inflection and discuss the concavity of the graph of the function. So this particular question, f of x, 2 sine of x plus sine of 2x. We have an argument of 2x, makes this problem a little more interesting. Things to come later. This function would be continuous on the interval they want us to check out. So everything applies. So first, find the points of inflection. We have to find the second derivative, find when the second derivative equals 0, and test intervals around those zeros. Let's get there. So find the first derivative, and then derivative of sine is cosine, and then we got cosine of 2x times the derivative of the inner function. All right, now let's find the second derivative. Derivative of cosine is negative sine, negative 2 sine x. Derivative of cosine would be negative sine. And then times 2. And finally we get negative 2 sine x minus 4 sine 2x. Okay, let's find the zeros, but here's the deal. We can't just factor a sine out because this is sine of 2x. We could graph this function in our calculator or online, any kind of graphing program. But we know sine of 2x, though, using our identities, equals 2 sine x cosine x. So make that substitution, and let's set the derivative, second derivative, equal to 0. Now, after we multiply 4 times 2, we can factor out a sine. And actually, let's not multiply 4 times 2. Let's factor out a 2 also. Let's factor out a negative 2 sine x. Negative 2 sine x. Look at that zero product property that we're looking for. Okay, that would be 1, and that would be plus 4 cosine x. And then we set each factor equal to 0. And divide by negative 2, we get 0 equals sine of x. Well, when is sine equal to 0? Well, sine is the height on the unit circle. It's the y value. When is the height equal to 0? Well, right here, and then back at 2 pi, if we go from 0 all the way back to 2 pi. So we have x equals 0, x equals pi, and then x equals 2 pi. Well, 0 and 2 pi are endpoints anyways on our interval. Up here, subtract 1, divide by 4, and you get negative 1/4 equals cosine x. Negative 1/4 is not one of those famous right triangle side ratios that we memorize, or 3/2, or 2/2, 1/2. Therefore, we're going to have to graph this, I would say, or use cosine inverse, but that'll only give you one value. Figure out graphically, put y sub 1 as cosine, put negative 1/4 as y sub 2, find the intersection. It should be in 2 places. You should get 2 answers. You can graph this using another utility. It's up to you. But when we graph this, we get x equals 1 point, well, again, approximately, and then x equals 4.459. And when we're checking this, I have my window or my scale, my graph, just set to include x values from 0 to 2 pi. All right, number line to check our intervals. Let's see here, we're starting at 0. We're going to 2 pi. And so sometimes, even though I already put my arrows on there, I like just to erase those arrows, erase the whole thing. because I remember not to go past these values. All right, 1.823, I got pi, and then we got 4.459. All right, take a value on this interval, substitute it into your second derivative. I would just use your calculator and your table feature and evaluate at, like, say 1, 2, 4, and maybe 5. Doing that, you'll get negative, positive, negative, positive. Since these are values, possible points of inflection, this is when the second derivative equals 0, and we have sign change of that second derivative, which means concavity changes. Therefore, here, here, and here, these three values are points of inflection. Now, if we want the point, we got to find f of 1.823. We got to find f of pi. And we need to find f of 4.459. All right, we don't know what's happening past 0 or past 2 pi, so we're not including those as possible points of inflection, even though the second derivative is equal to 0. Using a calculator, plugging into the original function, I get, let's see here, 1.453. I got 0, and we get negative 1.451. So answering the question, we got points of inflection at 1.823, 1.453, pi 0, 4.459, negative 1.451. And the reason why they're point of inflection, because f double prime x equals 0, and f of x changes concavity. All right, now we have to discuss the concavity of f. Well, we get that from our sign chart. F of x is concave up on, that's when the second derivative is positive, 1.823 to pi, and 4.459 to 2 pi, because f double prime x is greater than 0. F of x is concave down on 0 to 1.823 and pi to 4.459, because f double prime is less than 0.